all solar systems should come with a measure of real protection. Not only protection for people who are using the electricity from solar, but protection for the equipment in the system itself, which, as we know, can get quite expensive. So we're looking at two modules that we have here that are found at different points in the system. When we come straight off the panel, we have what is called a main DC disconnect. And this is pretty much the first point down the line from the panel themselves. And it's kind of like the first line of defense against things like voltage spikes or uncontrolled current passing out of the panels that would potentially damage components downstream. So what we have here are a series of fuses that are designed to be, I guess, assigned for different panels. So we see that we could put up to 6 panels in each one of these fuse lines. Now these fuses are rated to handle up to what are 20 amps. We'll be talking in other videos about things like the difference between volts, amps, and watts. So if you're not sure about amps, do check out our video on volts, watts, and amps. And so amps is the rate of flow of electricity. And so the higher rate of flow, the higher potential of overheating, overcharging, and then just simple danger of electrocution to equipment and to people. And to help prevent this is that each panel has to have its power pass through a fuse here. And what this fuse does is, like I said, it's the first line of defense against overcharging. So if there's this tremendous spike in power coming through, this takes the hit and gets fried, and thus stops the electricity from passing on through and out of the system downstream to the charge controller and the batteries and so forth. So although the power, of course, stops, it prevents damage to everything down from there, and we just simply replace the fuse, and it's only a few bucks, so it's okay. And you can see how here's the intake for the negative and positive of the solar, those MC4 connectors that is used in so much of solar nowadays. And as we can see, we have the potential to have up to 6 panels working together to build up power. And from there, they essentially combine on the positive and negative buses here that unite all the positive wires and negative wires. And that way, they can leave the system and out here and go on down the charge controller. What we have here is our main disconnect. And so this main disconnect is what it is. If we wanted to simply shut the whole system down so we can work on the system downstream from the panels, all we have to do is flip it like this, and boom, it's off. And then when we're ready to energize the system, you know, we're back again. So what we have here is a box that is serving many purposes. By having dedicated fuses, we can have a bad panel or a panel that's experiencing a power spike simply get thrown off, you know, and while that stops, the other panels can continue on. That way we don't have the whole system go down. We have the combination of power from all the panels into a single system. And we also have a point where we can just shut the whole thing off at one point and safely work on the system, whether we're needing to work with the charge controller, the batteries, the inverter, and so forth, anything downstream. So this is the important first line of defense for the DC end of the system. Once we've gone past the charge controlling, the battery banks, and the inverter, we have here, which is an AC disconnect. And this is an example of what you see in many homes called a breaker box. Now this, it would not be your main service box because it's only got room for a couple of breakers, and most homes have several circuits and would have several breakers. But if you have a fairly simple system where you're running just a few circuits, this is perfectly adequate. Now, whereas we have red and blue representing positive, negative, and DC, AC tends to be colored differently. So at that point, when you're in AC, your wires aren't, because they are alternating current, where it's not a specific positive and negative. We have the conductor and the neutral and the ground. And so the conductors, which are coded black wires, will go here and connect here, and then your neutral lines, your whites will go there, and then here's your ground where your bare ground wires go. Okay, so hot or black, white, neutral, and bare ground. And what happens is when we have too much power that exceeds the rating of the breakers, in this case these are rated at 15 amps apiece, it throws and just shuts the system downstream. And this is the way your breaker box at home, and all homes in the United States, work. And this, of course, is AC rated for like a 120 volt nominal system, as opposed to DC, which is right here. But regardless, both of these components are essential to protect both the equipment and the user from excess electricity passing through that could cause damage either to gear or to body.